Hello everyone. Today I'm going to present on the topic backtracking algorithm, which is an important concept in algorithm design. Backtracking is an algorithmic technique used to solve problems recursively by trying all possible solutions. It builds solutions step by step, and if a solution fails, it goes back and tries another path. So basically, it follows the idea try, check, and backtrack if needed. Backtracking works in three main steps. First, it builds solutions step by step. Second, if a condition fails, it undoes the last step. This is called backtracking. Finally, it explores all possible valid solutions until it finds the correct one. Let us look at the first example, the n queen problem. The goal is to place n queens on chessboard such that no two queens attack each other. That means no two queens should be in the same row, column, or diagonal. To solve this using backtracking, we place one queen in each row. Then we check if the position is safe. If it is safe, we move to the next row. If not, we backtrack and try another position. This process continues until all queens are placed correctly. Let me explain the Java code for the n queen problem clearly. First, we use a 2D array called board to represent the class board. Here, 1 means the queen is placed and 0 means the cell is empty. Next, we have a function called isSafe. This function checks whether placing a queen at a given position is valid. It checks three conditions. First, the same column. Second, the left diagonal. Third, the right diagonal. If any queen is already present in these directions, then the position is not safe. Next, we have the main recursive function. This function tries to place queens row by row. For each row, we try all columns one by one. If the position is safe, we place the queen by setting board row column equal to 1. Then we move to the next row recursively. If placing the next queen is not possible, we backtrack. That means we remove the queen by setting board row column back to 0. Then we try the next column. This process continues until all queens are successfully placed on the board. Here, we can see the output. The board uses 1 to represent a queen and 0 for empty space. This shows one valid solution for a forecast for chessboard. Now, let us move to the next example, the subset sum problem. Here, we are given a set of numbers and a target value. The goal is to find whether a subset exists whose sum is equal to the target. In this approach, we include an element and check the sum. We also exclude the element and try another combination. If the sum matches the target, we found a solution. If the sum exceeds or no elements are left, we stop. Now, let me explain the subset sum Java code. Here, we use recursion to check all possible subsets. We have a function that takes three parameters, the array, the target sum, and the current index. At each step, we have two choices. First, include the current element in the subset. Second, exclude the current element. If we include it, we subtract its value from the target. Then we move to the next index. If at any point the target becomes 0, that means we found a valid subset. If the target becomes negative or we reach the end of the array, we stop that path. Then we backtrack and try the next possibility. This way, the algorithm explores all combinations. Finally, if any combination matches the target sum, the function returns true. Here, we can see the output and the recursive process. The algorithm explores different combinations. Finally, it finds a subset 3, 4, and 2, which gives the target sum 9. Conclude, backtracking is a powerful technique used to solve complex problems by exploring all possibilities. It is widely used in problems like can queen, subset sum, and many others. Thank you for listening to my presentation.